format equations of straight lines. And up until this point, they've always been in that format of here, y equals x plus c. Okay? Now, this is a situation where sometimes they might start asking you to rewrite it in a slightly different format. This is going to be no different, so our process that we go through isn't going to be any different initially. It just means that at the final stage, you're going to have to be able to rearrange stuff. Okay? Now, it could be that you're sitting there thinking, oh great, I'm really good at rearranging stuff, or it could be like, oh Jesus, that's my bugbear and I don't mind doing it. But anyway, let's give it a bash. So, finding general form, the equation of a line through this coordinate and has a gradient of 1/3. So we're going to start off in the same way as we've done before. Okay, what would I write knowing that it has a gradient of 3? So I'm going to write y equals lovely jubbly. Jacob, what would I then do? Lovely jubbly. So I'm going to write 4 equals 1/3 multiplied by 1 plus 6. Layla, how would I rearrange to get C? Nice. Sophians. 4 whole 1 subtract 1/3 is 3 2/3, yes? Which is 11 over 3. Was that too much? Totally goes. So 4 whole 1s in terms of thirds would be 12 over 3. Yes? Because it's equally 4 over 1.
Yes. Did you cross multiply? Oh, okay. You did it. You just flipped it.
No. Okay, so I've got 4 whole 1s. Subtract 1/3. So because this is thirds, and currently my denominator is 1. Yeah.
Times by 3.
So because I'm subtracting, what do I have to do? I have to have the same denominator, yes? So I multiply both top and the bottom by 3. Okay, so I've got 12 over 3, subtract 1 over 3, gives me 11. Yeah.
So you just do 3 times 4 is a number 12, and then minus 1 is 11.
So I know that my equation is y equals, where is it? 1/3 x plus 11 thirds. Yes? So far so good? But the general form up here has a and b in front of x and y and equals to c. Now sometimes they may say ax plus by plus c 0. So just be aware that you could have either of those two formats. So either they want everything to one side, or they're going to have your x and your y is equal to the constant value. Either way, these values of a and b cannot be, or c, cannot be fractions. Okay, so a and b cannot be fractions, or c. So we're going to have to say to ourselves, well, what do we have to do, therefore, to this equation here to eliminate any of our fractions? Now, you will usually find that you just need to multiply by one value. Sometimes you may have to do it in a couple of stages, but usually just multiplying it by one thing will get rid of your fractions. So looking at this format here, y equals 1/3 x plus 11 over 3, what do you think we could do to this whole equation? What could we multiply it by? Cassidy, what do you think we can multiply this by to get rid of or eliminate my fractions? 3. Yes, you're happy with that?
Yes.
Because this is a third, this is third, so if we multiply everything by 3, we're going to get rid of this denominator. So remember you cannot just multiply the right hand side by 3. I'm going to have to multiply everything by 3. So that means I'm going to now have 3y. How many x's will I have? 1x. I'm going to write 1 because this is my working set. And what am I going to have as my constant term? Ashley, Stevens.
11.
Nice. Okay, so far so good?
Yes.
Now, at this point, I've eliminated my fractions, so you need to double check which format they want it in. So this would either be the top one. Now, usually if they've asked for the x first, they normally want that value to be positive. Okay, so it's unlikely that we would write negative x plus 3y equals 11. We would probably write x subtract 3y equals negative 11. You all happy with that? Okay, if you wrote this one, I have to hold my hands on my heart, I don't know. It will depend on the mark scheme. And the mark scheme may accept this, it may not. Okay, so I would suggest aim to always make your the first variable positive. So if I've got this as negative and I want it positive, you just change the sign of everything else. Well, everything. Essentially what you've done is multiply by negative 1. Okay, so I had negative x plus 3y because I subtracted x from both sides to bring them together. Okay, so I did have negative x plus 3y equals positive 11. And then I've changed it to x minus 3y equals negative 11. Obviously, if it was in that other format where everything's on the same side, I would have x subtract 3y plus 11 equals 0. So that would be the other format. And it really is just double checking which one they've asked for and trying to make the first term positive. Okay, so we're unlikely to leave the first term as negative. Was there a question coming out, Tanya, or do you need another 5 minutes to decide what it is?
It says 3y equals x plus 11. How do you get that to minus
To here? So I subtract x from both sides. Because I want to put my x and y together.
Oh, okay.
Yes, I just didn't write the 1.
Do you have to do that to make to give the x on the outside or on the other side?
Well, if I want to put it with the y, yes, I have to subtract x from both sides. I could have subtracted 3y and subtracted 11. I could have done that. So I could have kept this positive. There's different ways of doing stuff. What do you why?
Why can you go for like that?
You could, but specifically they've asked us to leave it in general form. Okay? So in some
y.
so it means it's going to look like one of these two. So we're up until this point we've only left it as y equals mx plus c. So that's leaving it so it looks like one of these two. That's what general form means.
So
It's some number of x plus some number of y equals some other number, or they're all together equals 0. The main reason for doing this would be later on when we look at simultaneous equations, and this is often how they are left in this format. That would be one of the reasons why we might do it, but if a question asks for it, you need to follow their instructions. Well, there's lots of questions. Alright? No, I'm not, darling. I'm making my way. I didn't know you had your hand up as long as everyone else. Anyway.
it's fine.
That's problem. Oh, you want me to ask me something about this?
Yeah.
What's that?
Can you write 3 lines?
Yes, you definitely can. But they've asked for the x first, and so they want the x value. So I said keep the first term positive. Yes.
Is the 11 positive in that answer because if you round it over?
Yes. Thanks.
Can you leave it as x and rewrite it with negative 11?
It would, yes, it would depend. So if it was this top one, yes.
No difference?
Yes, definitely, because that's correct.
So
So my-
like the formula, we don't have to memorize it.
No, it didn't, well, they should say in the question which format they want it in. So they will probably say X plus BX, BY, C, whatever. We'll see if we can find some questions that show you what they're doing.
So after you want this X for those sides.
Yes, because we need to make our first term, so in this case it happens to be the X, to be the positive one. So because this is not positive, so that's what Aria just said. This is exactly the same as this, but I have my Y and my first term is positive, but my Y is positive, and they've asked the X to come first. And so that's why we had to go to this format. No, that can be a subtract. Okay? Right, so we've been given the gradient and a coordinate there, so that was our initial same method. Here we've been given two coordinates. Again, first thing we have to do is find the gradient. So our gradient for this one would be 1 subtract 4 over 5 subtract 8. 1 subtract 4 is -3, and 5 subtract 8. -3, yes? -3 divided by -3 is 1. Positive 1. Okay, so we have a gradient of 1. So my starter is y equals x plus c. So I know that. Now, which coordinate shall we use? I don't mind. You don't have to do that. No, because our n is 1. If you want to write 1, that's fine. Now we're going to do that. Yes? So which one do we want to use? A? Alright, so we're going to say 4 is equal to 1 multiplied by 8 plus c. So c is -4. So our equation is y equals x subtract 4. Okay, we don't need to deal with any fractions here, thankfully. Okay, so we don't need to deal with fractions, but we do need to make sure everything's on the same side. Or let's show that something else. We need to put it in the right format. So I'm going to subtract x from both sides. So I've got -x plus y equals -4. Or in this case, it could be x subtract y equals +4. So that would be my format if it was the first option. And if it was the second, it would be x subtract y subtract 4. No, what have I done? No, that's right. Equals 0. Alright, so two coordinates. We're going to find our gradient. So we've got -3 subtract 4 over -2 subtract -2. So what's -3 subtract 4? -7, and -2 subtract -2 is... Now, what does that tell us about this line? It's undefined. So what do we know about undefined lines? What do they look like?
They're straight.
They're straight.
Vertical. Oh, they go straight through the...
Horizontal. The horizontal.
They go through the line.
But they're vertical.
I
See, please. So there, because we know it goes through, because it's got a 0 at the bottom, it's undefined, which means it's a vertical line. And vertical lines always have the equation of x equals a value. What value is our x going to equal? No.
0.
No.
A number.
Go back to the coordinates. What's our x value? So that is our equation for this line.
Wait, what?
It's undefined. So then you want to add the first
Okay,
number to each
ladies, I know you're trying to help, but just keep shouting down. So vertical lines always have the equation of x equals something. Okay, you all happy with that?
Yes.
So undefined gradients are vertical lines. Vertical lines always have the equation of x equals whatever number it is. So to establish which number it is, we're going to look at the x coordinate that we're interested in. So our x coordinates both happen to be -2, therefore the equation of this line is x equals -2. Now, putting it in this format, this would be it. X equals -2 for the first one. Our y coefficient happens to be 0. If it was the blue format, we would have x plus 2 is equal to 0. Again, the coefficient of y is still 0, but everything's on the same side. Several hands up. Ashley.
What happens when it's negative? What do you do when the x coordinates aren't
They would be. If they weren't the same, you wouldn't have an undefined gradient. No, that's what Ashley just said. You wouldn't have 0 on the bottom if they weren't the same x coordinate. Because I just looked at them because they're the same. They would have been. Yes? Is that what your question is? Yep. Remember, so vertical lines, I don't know why I supposed to do that one. Vertical lines are always of the format x equals something. But, so, slopey lines are y equals mx plus c. But vertical lines are always x equals. That's why I taught you that bit first, because I can teach it after it. Sometimes people get a little bit stressed out. Obviously, get a bit stressed out. Alright, so if given the equation in general form and asked to draw the line, you might want to rearrange it to y equals mx plus c. Okay, so we've done stuff like that several pages ago, where we were given it in a different format, we rearranged it to find the gradient y-intercept. However, if it is in this format, rearranging could cause you a bit of an issue. If you want to find your x and y intercepts another way, what you can do is substitute the value of y to be 0 in order to find your x-intercept. And you would find your y-intercept by that substituting the value of x as 0. Okay, so what was that all about, Ms. Harrison? So if I want to find my x-intercept, I know that the value of y would be 0. So to find my x-intercept, I would say x plus 3 lots of 0 would equal 6. And so x is equal to 6. So that's where it crosses the x-axis. To find my y-intercept, I know the value of x is 0. So I would say that 0 plus 3y is equal to 6. Therefore, 3y is equal to 6. And y is equal to 2. So I would be able to then draw that line knowing that it goes through the y-axis at 2 and the x-axis at 6. And so I would be able to draw my line, oh, that wasn't very good, like that. Okay? And that would be our second example. Again, you would find you'd plot those 2 points and join them up.